What's happening, you guys? Mr. Allen here, and we're about to write a polynomial function with real coefficients that has zeros at x equals 3, x equals -1, and x equals 4 minus 3i. Imaginary numbers, bro. This is going to get crazy. You know, everybody calm down. Calm down. Just calm down. First off, I'm going to write down my complex conjugate. Right? That's going to be 4 plus 3i. If I got one, I got to have the other. Right? It's the buddy system in imagination land. This is too dangerous to go there alone. You got to have both. If you have one, got to have the other. All right? Cool. Awesome. Fantastic. So this is going to be a quartic function in the end. Let's start writing this thing out in factored form. And I'm gonna need some room here. So we got f of x equals, I got x minus 3, easy money. We got x plus 1, lovely. Now it gets crazy. I'm going to have x minus, parentheses, 4 minus 3i, close them, and x minus 4 plus 3i, close them. Now, what I'm going to do is I'm going to work with the imaginary stuff that's happening on over here. Keep these realist ones on the left ones just chill. Okay, we're going to come back to them in just a sec. All right, so on the right-hand side, I need to, or in the right half of this problem, distribute that negative into my binomial there. So I'm going to have x minus 4 plus 3i, and I'm going to have x minus 4 minus 3i. Now, what you might notice is the x minus 4 is appearing in both of them, and that is very, very important to notice. I can group them. Okay, and what I'm doing is I'm setting up the situation that multiplies out like the difference of two squares. Okay, so when I multiply these two, I get negative 3i times x minus 4. And over here, I get positive 3i times the quantity x minus 4. Those are going to cancel. So I don't even have to do the O and the I of FOIL. It's just going to cancel out. Saves me a whole lot of mess, a whole lot of time. I'm going to multiply these two together first. X minus 4 times x minus 4 is going to give me x squared minus 8x plus 16. We should be able to handle that in our head, all right? You should be able to FOIL those two same ones out in your head. Don't forget about that middle term. Then I have 3i times negative 3i. That's going to be negative 9i squared, and since I squared is -1, I'm going to get plus 9. This type of problem has so much work, it can be helpful if you can do a few steps in your head. So now I have x squared minus 8x plus 25. And now I'll bring these two back together. And why not? Why not multiply these two together right now? Shall we? Let's do it. X times x is going to be x squared. And then I have, let's see here, this is going to be negative 3x and positive 1x, so minus 2x. And then we have negative 3. So we'll just bring that guy right down here. And now I have to multiply two trinomials together. So let's be really, really, really careful here. We got x squared times x squared. That gives me x to the 4th. Then I have x squared times negative 8x. That's going to be negative 8x cubed. Woo! Really trailed off there. So now let's combine our like terms, shall we? So I got x to the 4th with no other like terms. So we're just going to have x to the 4th power. Then I have my cubes. I got negative 8x cubed. I have negative 2x cubed. That gives me negative 10x cubed. Now to my x squared like terms. 25, 16, that's 41. 41 minus 3 gives me positive 38x squared. Now onto my linear terms. We have negative 50x and positive 24x. That's going to be negative 26x. And then lastly, my constant, which is negative 75. Don't forget your lovely function notation. And there we have it. A quartic polynomial in standard form here. We have real coefficients, right? All real numbers here, no imaginary numbers. That's it. We followed the directions. That was a doozy, but do not forget about this wonderful step right here, that grouping that saves you some time, some writing, and that's dope.